A turbine is a device used to generate continuous energy that is made up of a shaft or a wheel that has several vanes attached to it and moves due to it: gas, steam, water, and wind. The benefits of a turbine: use it to generate electricity due to dynamo or to create movement, like a turbine in an aircraft. History of a turbine: it has been used throughout history and is very old invention, but in simpler and simpler way than it's now. The Romans were the first to use water ash to green wheat flour 17 years ago. Types of turbines: gas turbine, a device that works by combustion or combustion that converts natural gas into mechanical energy. How gas turbines work: the air solution combines with natural gas, which leads to the formation of a hot gas. The hot gas circulates the vane of the turbine.
Air. A lot of gaseous molecules floating all around us. It's great for breathing, and it turns out it's great for getting lights turned on. That's because air, along with abundant natural gas or other fuels, are the ingredients that combine in a gas turbine to spin the generator that produces electric current. If you follow the electricity you use at home or at work back through the power lines to your local power plant, you'll see that the process most likely starts with the work of the gas turbine, the very heart of the power plant. First, air is drawn in through one end of the turbine. In the compressor section of the turbine, all those air molecules are squeezed together, similar to a bicycle pump squeezing air into a tire. As the air is squeezed, it gets hotter and the pressure increases. Next, fuel is injected into the combustor where it mixes with the hot compressed air and is burned. This is chemical energy at work. Essentially, this is what happens in your family car's engine, but at about 2,900 times more horsepower. Actually, it's exactly like the turbine engines on jet airplanes. The hot gas created from the ignited mixture moves through the turbine blades, forcing them to spin at more than 3,000 RPMs. Chemical energy has now been converted into mechanical energy. The turbine then captures energy from the expanding gas, which causes the drive shaft, which is connected to the generator, to rotate. That generator has a large magnet surrounded by coils of copper wire. When that magnet gets rotating fast, it creates a powerful magnetic field that lines up electrons around the coils and causes them to move. The rotating mechanical energy has now been converted into electrical energy, because the movement of electrons through a wire is electricity. In what's called a combined cycle power plant, the gas turbine can be used in combination with a steam turbine to generate 50% more power. The hot exhaust generated from the gas turbine is used to create steam in a boiler, which then spins the steam turbine blades with their own drive shaft that turns the generator. What you end up with is the most efficient system for converting fuel into energy.
The benefits of gas turbine: it is smaller than most other devices that produce the same energy. It rotates in the same direction, which leads to less earthquake. The moving part is small. There is a lot of speed, a little pressure on it. Big points of gas turbines: it costs a lot to build. Late responses to changes in energy. Water turbine: the device converts turbulent and liquid motions to mechanical motions, which were developed in 19th century and have been widely used to generate electricity. How the water turbine works: moving water is directed to the pages, which leads to the rotation and regeneration of energy.
Hydropower. Hydropower, or hydroelectricity, refers to the conversion of energy from flowing water into electricity. It is considered a renewable energy source because the water cycle is constantly renewed by the sun. One of the first uses of hydroenergy was for mechanical milling, such as grinding grains. But today, modern hydro plants produce electricity using turbines and generators. The mechanical energy created by moving water spins rotors on a turbine. This turbine is connected to an electromagnetic generator which produces electricity when the turbine spins. There are two main types of hydroelectricity production: dams and run-of-river. Hydro dams utilize the potential energy from dammed water to produce electricity. A dam is a large barrier constructed to raise the level of water and control its flow. The elevation created by the dam creates gravitational force for turning the turbine when water is released. Some dams also contain an additional reservoir at their base where water is stored to be pumped to the higher reservoir for release when electricity is in demand. This is referred to as pumped storage hydro. The second form of hydroelectricity production is run-of-river hydro. Run-of-river still uses turbines and generators, but relies on natural water flow rates of rivers, diverting just a portion of the water through turbines. Because run-of-river hydro is subject to natural water variability, it is more intermittent than dammed hydro. There are various sizes of hydro plants that produce electricity. Large hydro, greater than 30 megawatts, small hydro, 100 kilowatts to 30 megawatts, and micro hydro, less than 100 kilowatts.
The benefits of water turbine. It works with water and does not pollute the environment. Every country can use it because there is water in every country, not like gasoline and gas. Weak points of water turbines. It costs a lot to build, harmful to fish. It wants a spacious place. Water shortage problem.